Welcome to the oscilloscope wizard. I could still hear myself in the background riding a bike, and it was throwing me off a little bit. But it's Baby Friday. You have made it to the show. Thank you so much for joining this morning. I have a timer. We're going to try to stick pretty close to the timer today. You know, ish. It is Baby Friday, so we're a little looser today. I realized that I forgot to grab my Good and Plenty's, which was a little bit of a bummer. But we are still on our quest. Let's see if we can get our quest up and running here. Yes. The problem we have right now, we have many problems, but the problem we have with our DIY Sonos style amplifier based on a Raspberry Pi is that when I set the volume to 0, no volume, I still get sound, which is sad face emoji. I don't know how to put emojis in here. I don't know. I wish I did know how to do emojis, but I don't. And here is what we are working with today. So everybody is very familiar with the box, and we have a lot of stuff installed in the box now, including we got our LED light ring on the front, which is cool, right around our rotary encoder. And then as we push further into the box, I wanted to show you, I have a lot of test equipment hooked up today. On the speaker outputs, I have these giant probes. I'm using my differential probe to look at the speaker output today. I'm using my multimeter to look at 1/2 of my digital potentiometer down here. It's got the DF robot sign on it. One of my wires broke going into my amplifier, so that's a bummer. That is the left channel. Good news, we're looking at the right channel, so I wasn't totally bummed. And I'm gonna have to do some rewiring. I've realized more angry cicadas are in my setup. And then I have 2 just regular old oscilloscope probes plugged into my amplifier input so that I can see the voltage going across my digital potentiometer, because it is driving me crazy that I cannot get 0 volume to equal 0 volume. I have drawn some pictures using my artwork to at least describe what I have set up. So what I have set up is the audio input comes into my potentiometer. It hits, we'll call this resistor A, and then it goes to the audio output. On the other half, I have a second resistor, resistor B. This is the other half of the potentiometer that is tied to ground. And the way I wired it is like this. So audio comes in, hits resistor A, and then audio goes out to the amplifier, and the relationship between these 2 resistors changes as I change my potentiometer, and that changes the size of the signal going to my audio out, which is then amplified, goes into my ear holes. That's how all this works. What's happening though, when I take my volume to 0, according to the data sheet, and in fact, if I was to look over at the data sheet, we can read it all together. Let's see. Shutdown. Shutdown, a software shutdown feature is provided that disconnects the A terminal from the resistor stack and simultaneously connects the wiper to the B terminal. So what it does is it opens up the A terminal and leaves it floating and shorts the B terminal to the wiper. So what does that look like? It's a lot of English words, but what that looks like is the A terminal is now gone. So this resistor is now gone. And I have the B terminal shorted to the wiper. So that means my audio amplifier's input, the audio output side of my digital potentiometer is now shorted to ground, but the signal coming in is just allowed to pound into the plane. So it just is left open, but also firing voltage into my fairly sensitive to noise amplifier board. As we're finding out more and more, our amplifier board is very sensitive to noise. I mean, as you would expect it to be, it is an amplifier. Amplifiers are inherently sensitive to noise because their whole lot in life is to amplify signals. So another way, I have wired it the most straightforward way. I have run my audio signal into point A, I have run my audio output from the wiper out, and then I've tied this side to ground. That is what I have done. That was the most straightforward way to wire it. That's how the old potentiometers were wired. So I just stuck with it. But another way to wire it is when my audio comes in, I could wire it so that I short the audio input signal to ground. And as being pointed out in chat, when this device shorts a signal to ground, it says it is connecting the wiper to terminal B. The wiper itself has an inherent resistance, and the wiper resistance is up to 125 ohms. So that means when you shut this down, you think that you're going straight to ground, but you're actually going through a 125 ohm resistor, so there's still a tiny resistance. But on the other side of the equation, you end up with 400 and something thousand ohms. And so let's just take a look at this really quickly. We can set this up. If I go to my Raspberry Pi controller, and let's just set this up really quick. So last time we did get the volume knob controlling volume. That was a thumbs up. So if I go back to where I was, let's see, sudo python 3 volume LED python. All right, that's running. Now I go back to my webcam. We should see the LEDs change as I turn the volume up. Yep, so the volume is working. And you'll notice in the background here, my digital multimeter is changing. So this is measuring the voltage between the A terminal and the wiper. So when I disable the digital multimeter, it should open up the A terminal from the wiper and leave the A terminal floating. What does floating mean? So if I measure the resistance between the A terminal and the wiper, I think it should be infinite. Floating means infinite, but it is a very small device. So floating in this case means 390 kilo ohms, that's a lot of ohms compared relative to a short. So let's move a wire and figure out what the short is. So this is going to be me moving a wire, a tight, tiny wire, live. We'll see if I let the smoke out. I have let the smoke out in the past. Also see if I shock myself. I'm going to move it over to the B terminal. So now, this is the short between the B terminal and the wiper. You can see it is 170 ohms. If I take out all these extra wires and doodads, it ends up being about 125 ohms, but not 0 ohms. So now my open is actually about 400 kilo ohms, and my short is about 178 ohms. But what does this actually mean for my sound? So I told you I have this thing hooked up to my oscilloscope. So let's turn on my oscilloscope and take a look at what is happening there. Channel 1 is hooked up to the signal on the A terminal of my potentiometer. So let's go back to my picture so we can see how we have it hooked up. Channel 1 for my oscilloscope is hooked up right here on my circuit diagram. Channel 2 is hooked up right here on my circuit diagram. And then if I go over to channel 4, that's hooked up to my speaker output. So I am looking at my audio input, my audio output to my amplifier, and then my speaker output on channel 4. and we should be able to see signals if I run. So I'm going to now connect to my amplifier with my iPhone using AirPlay, which honestly is pretty magical in and of itself, but we should see signals right away. Okay, so I see a signal on the input, so that's channel 1. That's the signal trying to get into the amplifier. In channel 2, no signal. That's good because my volume is set to 0. Now if I increase my volume, channel 2 will start becoming louder. And eventually I'll start seeing a signal over here on, you can see, now we got, I'm almost at full volume, but not very high volume on my source. So my source volume is pretty low, but my amplifier volume was high. Anyway, my source is the AirPlay source. So let's take a look at what is happening when I set the volume all the way to 0. So this is the volume all the way to 0. If I go back, we can see, because A, my lights are all out, and B, my digital multimeter is telling me it is at 178 ohms. So that means the digital potentiometer is disabled. Now my problem is when I set it to 0 and I crank my source volume all the way up, I still hear stuff. What is the deal, guys? What is the deal? So you'll notice that channel 1 on the oscilloscope was going crazy. So I'm going to let this play for a second. We're going to deal with the horrible sound coming out of the speaker, all in an effort to, actually, you know what? We don't need to deal with the horrible sound coming out of the speaker. I could disconnect the speaker. But part of me wants to measure the noise getting out to the speaker too. So this is 0 volume. Again, the amplifier set to 0 volume. Okay, so we can hear it. We can see it on channel 4 coming out. Let me real quick, so we confirmed everything. Let me real quick disconnect the speaker so that we are not dealing with that sound. And also, it's kind of an annoying sound, honestly. It would be a bummer if you bought an amplifier and turned the volume all the way down and that's the sound that came out. You'd be like, ah, what? This feels like a total dad operation. Barely working and highly unsafe. Okay, now the speaker is disconnected. Sorry, I put the speaker up beside me so that so that I could hear it a little bit better and hold the microphone in front of it a little bit more easily, which was good, but also highly annoying. Now, we're not going to hear anything, but we should still see the signals on the oscilloscope. Let's see. Yep, see? So if we had a speaker connected, we would still be getting sound you can see on channel 4, which is not what we want. And channel 1 is going crazy. So I had this set to 10 millivolts division. So if I want to put channel 1 and channel 2 on the same scale or on the same grid so that you can see that channel 1 is huge and it is bleeding over to channel 2, even though these two pins have how much resistance? They have 400,000 ohms of resistance between channel 1 and channel 2 right now. But if I go back, I have left this signal open. So it's able to fire all its voltage into my board. I am not shorting that signal to ground. So when I leave a signal open and able to basically, if I'm sending voltage into an open port on my board, I can expect EMI to fire out into the board. It makes like a tiny little antenna inside of my printed circuit board. And I think that is what is happening right here, guys. So I just am curious, like, how big is this signal? Goodness. Let's look at the scope screen really quickly. So here is my audio input. This is channel 1 coming in. Channel 2 is the channel going into the audio amplifier. You'll notice that that is big enough. Let's see how big the signal is going into my audio amplifier. So if I do peak to peak of channel 2, let's turn on statistics for that measurement group as well. Okay, so I have 2.7 volts firing into an open. And then I have 27 millivolts going into my amplifier input pin. And this is generating sound on my output. Oh man, that's no bueno. That is no bueno. There are a bunch of different ways I could attack this. The first way though, I want to try to, I'm occasionally even clipping here. So I'm going, let me make this a little bit bigger here. Make it 1 volt per division. Yeah, I'm going above, so 3.7 volts. That's a really big signal coming in. So one of the things I thought is I could, as I was saying, short the audio coming in to send all that energy to ground, just directly to ground, and hopefully it won't make it over to my channel 2. It looks like channel 2 is clipping too a little bit. You can see the little red up and down arrow there telling me that it's clipping a little bit. So put it on the screen, all on the screen. Yeah, 3.7 volts are allowed to fire in, creating a ton of noise on my board. And then 27 millivolts are making it to the audio amplifier, which is then generating a signal on my speaker. Oh, and my mom made it. Hey Mom, thanks for coming. I appreciate it. Let's rewire this a little bit. If I go back over, look at my wiring diagram that I have. So this is currently what I have wired up. Audio is allowed to fire in with no governor at all. It is generating essentially EMI inside of it's really just generating noise inside of my board because I've left it to just fire away. What I could do is tie the audio input to the wiper pin. Now when I disable the potentiometer, the audio in would be shorted to ground with, well, 120 to 170 ohm resistor. And the audio output would have a 400 kilo ohm resistor in between it. And so I'm gonna try that. Let's just move some wires. It's pretty simple. We're gonna move a couple wires and make it happen. So we are gonna do this while also attempting to not short anything out. Let's see. I want to do it so you can actually see what I'm doing, but I'm going to take this wire, which is my wiper wire. So now my signal would completely go away. So this is the wire in my right hand right here that I'm shaking is potentiometer A pin. So this is opened up right now. If I can. It's a little hard to do it on camera. Moving wires is a little hard to do on camera, guys. I can understand why a lot of people don't do this. And now my wiper is tied to my audio input. So now I have, oh my gosh, oh my gosh, oh my gosh. Scared me to death.
5 minutes remaining.
As usual, scared me completely to death. That's fine. That is fine because this is what I have wired up now. So I have my audio input going to ground. My audio output has a 400 kilo ohm resistor. We're going to call that an open. We're going to call it an open. It's not a real open, but we're going to call it an open, just like the datasheet calls it an open. It's funny. Datasheets can call it whatever they want, folks. So my amplifier or my potentiometer is still off. And now let's look at the scope. you'll notice my signals are much lower. So if I reset this, resets my statistics, my audio input is only able to drive up, let's see, let's get a loud song going. 1.44 volts. Before this was up to nearly 4 volts, it was 3.9 volts. And the signal coming into or going out to my speakers is still there, but it's not as loud. So another idea that I had was what if I reduced the voltage on my digital to analog converter? Because the voltage level going to my DAC chip is actually setting this volume coming out. So what if I'm just overdriving that input and it's just more than that little potentiometer can handle? So I have this, if I can point it, we can see it here. This little voltage regulator is controlling the voltage going to this digital to analog converter chip. So if I reduce this below 3.3 volts, I think it can operate as low as, what can it operate as low as? If I go back up to my desktop, let's figure out, do I have, so this is my TPA, what is I am using a PCM5102A, right? 50, this one. This is my digital analog converter chip. What can it operate down to? So it says 3.3 volts, but it's going to have a plus or minus on that. .3. Well, okay. So it looks like I could have anywhere from minus 0.3 up to 3.9 volts. So it's a pretty wide range. Okay, so let's turn the voltage down on that. And as I turn the voltage down, we're going to watch the signals on the oscilloscope to see how they react. I haven't tried this yet. We'll see if I fry something in doing this. I know breaking all the rules, changing voltages while things are on, that is never a spectacular idea. I think it's a spectacular idea. All right, right now it's about 3.4 volts. Go down a little bit, 3.1 volt. Okay, the signals are still signal coming out to the speaker. I'd like no signal going out to the speaker. 2.9 volts. Still signal going out to the speaker. 2.5 volts. All right, no, I don't think there's signal going out to the speaker now. Let's see, does it? Let's hook up the speaker really quickly and see if we have sound coming out. It looks like we may. Looks like we may, but I'm not sure. And click this back over so you can see me attempting to not shock myself and hook up a speaker. That exciting combo. Okay. Positive terminal of the speaker. Negative terminal of the speaker. No sound is coming out. Oh, there's a buzz. Not sure that's good. There's a slight buzz coming out of the speaker. You can hear it. I think that might just be the angry cicadas. I think this might just be a wiring issue. Yeah, that's just the angry cicadas. That is just happening. But if I turn my voltage back up, that's going to that digital analog converter chip, do we hear stuff coming to the speaker? I still have sound playing. Yeah, see? You can hear it. So it was up at 3.3 volts. You can hear it defeating my potentiometer. But if I turn it down to, let's see, we're down to 2.8 volts. Nothing. Nothing. I do have some weird stuff happening on the speaker amp. But we solved the problem. We solved the problem, guys. We rewired it, so now that my audio comes in and is shorted directly to ground. Let's see, can you see it? There you go. Audio comes in. Oh, we can barely see it because it's white. Audio comes in, goes to ground. And that keeps the signal from getting loose in my board. So I guess one of the things I've learned is maybe don't leave channels open coming into an amplifier board, because that is going to lead to noise getting loose in your board. So if a signal is supposed to be damped or quiet, then short that thing to ground through a resistor, or keep it from running loose through your board, because it's only going to generate noise. That's it. That's it. So one wire change. I didn't have to change the potentiometer. That worked fine. There was nothing wrong with the resistors values being 100 kiloohms or 400 kiloohms. That was all fine. It was really how I had wired the potentiometer that was causing that noise to get in. And then maybe the digital analog converter chip just driving too much volume out, and the potentiometer couldn't handle that much noise getting through it. So reduce the voltage on the digital to analog converter chip, rewire the digital potentiometer, like move the wiper, exchange the wiper and the potentiometer A pins, and that solved the problem. I think I'm going to call it good. I still need to figure out what is causing the buzz in the speakers. I think that, though, is still the old Raspberry Pi's noise getting loose, and I think that is going to require me kind of rethinking how I am, my board layout. Basically, maybe I need to change the position of the Raspberry Pi relative to everything else. So right now, let's see if I can get this thing high and pointed down. Yeah, there we go. Right now, my Raspberry Pi is right here. I got wires running everywhere. I also stuck up these wires, which leaves a nice little antenna for signals to get loose on. Again, not a great idea. But I probably need to rewire this, and I need to make this a little bit neater. And I also need to think about a wiring bus bar or something that I can hook the wires to before the Raspberry Pi is installed. And I have a couple of little pieces, a couple little boards and adapters that I think will fit that bill. It'll allow me to essentially wire everything up before the Raspberry Pi is installed, and then install the Raspberry Pi with just a cable into the whole system. And I think I might need to shift components from one side to the other to keep them far away, keep my analog circuitry away from my digital circuitry, which is a constant struggle. Because digital circuitry, wonderful for logic and user input and everything, terrible for anything to do with analog electronics, because digital edges are super sharp and have lots of harmonics and noise, and analog edges are smooth like the top of the ocean. So in real life, designers have to spend a lot of time keeping their analog circuitry away from their digital circuitry. That was the show, guys. That was the show. Hopefully you stuck with me, and we have done tons of measurements with our oscilloscope. We've used our multimeter today. It's a wonderful day when you get to use a ton of test equipment, and it's an even better day when you use the test equipment to solve a problem, and it works. My mom says I write tiny. I do write tiny. That is true. That is, I cannot physically write larger. I try, but I cannot. Baby Friday, thanks for joining. Next week, we're going to do silly things like change the color of our LEDs based on the source that is playing. So green for Spotify, blue for Bluetooth, maybe white for AirPlay. I want the LED to pulse ominously when the amplifier goes to sleep. So that'll be cool. So tune in next week. We're going to do more with our NeoPixel, more with our Raspberry Pi DIY Sonos style amplifier. And then we're going to be finished. I think we're going to paint it. I'm going to put it in the garage. I'm going to start listening to it. And then we're going to move on to our next cool project. So if you have cool project ideas, let me know and I will consider them. As always, I don't know all the nerds in the world and I would love to meet them. So please share this with a nerd in your life. And I will see you guys next week. I'll hang out in the chat. Talk to you later. Bye.